Look in a mirror right now. The color staring back at you feels permanent. It feels like it's always been this way, like it's carved into you as deeply as your fingerprints. But the real answer is far stranger. Every human being alive today descended from dark skinned ancestors. Every single one. Not most, not many, all of them. And the pale skin that millions of people now consider their birthright is, in evolutionary terms, barely a blink old. Here's the number that should stop you. Modern humans have existed for roughly 300,000 years. Pale skin, the kind common across much of Europe today, may only be about 8,000 years old. Do the math. That means for over 97% of human history, every person on Earth had dark skin. Not just in Africa, everywhere, including the frozen edges of Ice Age Europe. So what happened? Why did skin color change at all? And why did it change in some places and not others? To understand this, you have to go back nearly 2 million years to a moment that had nothing to do with color. It had to do with hair, or rather, the loss of it. Your earliest human ancestors were covered in fur, just like other primates. But somewhere around 2 million years ago, something shifted. Early humans started walking longer distances, hunting, tracking prey across open savanna under a brutal equatorial sun. Fur that once offered protection became a liability. It trapped heat. A furry body running down prey in the African heat risked overheating and dying. So natural selection did something radical. It stripped the fur away and replaced it with something better suited to endurance. Bare skin, covered in sweat glands that could cool the body through evaporation. But bare skin created a new problem. Skin without fur is skin exposed directly to the sun. This is where anthropologist Nina Jablonski enters the story. Along with her colleague George Chaplin, Jablonski spent years mapping skin color against sun exposure data from satellites, publishing groundbreaking research in the year 2000 that reshaped how scientists understood human pigmentation. Their finding was elegant. Skin color across the globe correlates almost perfectly with the intensity of ultraviolet radiation, or UV, the invisible part of sunlight that can damage living cells. Near the equator, UV radiation is intense year-round. Newly bald, sweaty-skinned early humans living there faced a hidden danger. UV rays don't just cause sunburn. They penetrate skin and destroy a nutrient called folate, a B vitamin essential for making healthy sperm and for the proper development of an embryo. Too little folate, and reproduction itself suffers. Miscarriages, birth defects. In evolutionary terms, that's about as costly as it gets. So the body needed a shield, and it already had the tool for the job: melanin, a natural pigment produced by cells in the skin. More melanin means darker skin, and darker skin blocks far more UV radiation before it reaches those folate-destroying depths. In other words, dark skin wasn't a default. It was an adaptation, a sunscreen built by evolution, worn permanently, generation after generation, by every human who lived near the equator. For a long stretch of human history, that was the whole story. Dark skin, everywhere, because early humans hadn't left Africa yet, and the sun over Africa doesn't negotiate. Then humans started walking, out of Africa or north, into regions where the sun behaves completely differently. Picture what that migration actually meant for the human body. In equatorial Africa, the sun sits high in the sky for most of the year, delivering strong, direct UV radiation. But travel far enough north into what is now Scandinavia or the British Isles, and the sun sits low on the horizon for much of the year. Its rays travel through more atmosphere before reaching skin. UV intensity drops dramatically, especially in winter, when some regions receive barely any UV strong enough to trigger the reaction human skin depends on. And that reaction matters more than you might think, because skin doesn't just block UV, it uses a small amount of it. When UV rays hit skin, they trigger the production of vitamin D, a nutrient essential for absorbing calcium, building strong bones, and supporting immune function. In sun-drenched regions, this was never a problem. Dark skin still let through just enough UV to manufacture vitamin D while blocking the rest to protect folate. But in low UV northern regions, dark skin became a liability instead of a shield. It blocked so much of the already weak sunlight that bodies couldn't produce enough vitamin D. Over generations, this created a new and different kind of pressure. Deficient vitamin D leads to rickets, a disease that softens and deforms growing bones, and to weakened immune systems, and to complications in pregnancy and childbirth. Suddenly, in these dim, high-latitude environments, having less melanin wasn't a cosmetic accident. It became an advantage. Lighter skin let more of the scarce UV radiation through, allowing enough vitamin D synthesis to keep bodies functioning and reproducing successfully. This is the actual mechanism behind the shift from black to white, not gradual fading like a photograph left in the sun. A trade-off. A constant negotiation between two invisible threats. Too much UV destroying folate near the equator. Too little UV blocking vitamin D near the poles. Skin color across the world is essentially a map of that negotiation, frozen in the bodies of the people who live there. Here's where the story takes its most counterintuitive turn. You might assume that once early humans reached Europe roughly 45,000 years ago, their skin lightened fairly quickly to adapt to the dim northern sun. That was the standard assumption for decades. But in 2015, a team led by geneticist Ian Matheson analyzed ancient DNA from dozens of skeletons scattered across Europe, some over 8,000 years old. What they found upended the timeline completely. One of the most famous of these skeletons is known as Cheddar Man, a roughly 10,000-year-old individual discovered in a cave in Britain. When scientists finally sequenced his DNA, the results stunned even the researchers. Cheddar Man, an early inhabitant of what is now England, likely had dark brown to black skin, and strikingly blue eyes. Think about that. 10,000 years ago, in the same misty, low-sun landscape that today produces some of the palest skin on Earth, people were still dark-skinned. Pale skin hadn't arrived yet. Not even close. Matheson's research suggested that the genetic variants responsible for light skin in Europeans, particularly a gene called SLC24A5, didn't become widespread until somewhere between 8,000 and 5,000 years ago, likely spreading through migrations of farming populations moving in from the Near East. Why does this matter so much?
Real quick before we continue, take a second to hit the like button, subscribe to the channel, and turn on the bell. It helps me keep making videos like this. All right, let's get back to it.
Because it means pale skin isn't some ancient foundational trait of European identity stretching back tens of thousands of years. It's a remarkably recent evolutionary event, younger than the pyramids of Giza, younger than written language in some parts of the world, a population that lived in cold, low UV Britain for tens of thousands of years remained dark-skinned that entire time, likely relying on vitamin D-rich diets, like fatty fish, to compensate for what their skin alone couldn't produce. And there's a second twist hiding inside this story, one that makes the whole picture even stranger. Light skin didn't evolve just once. It evolved independently, multiple times, in different populations, using different genetic tools. Europeans developed light skin largely through variants of the SLC24A5 gene. East Asian populations, migrating into similarly low UV regions of Northern Asia, developed lighter skin too, but largely through an entirely different gene, OCA2, along with other distinct genetic pathways. Two populations, separated by thousands of miles and no direct contact, arrived at a similar outward result through completely different internal routes. This is what biologists call convergent evolution. It's the same reason bats and birds both have wings despite having no shared flying ancestor. Nature, faced with the same environmental pressure, sometimes finds different paths to a similar solution. Low UV plus insufficient vitamin D production created pressure toward lighter skin wherever humans settled far from the equator, whether in Northern Europe or Northern Asia, and evolution answered that pressure more than once, independently, with different genetic machinery each time. Here's a name that rarely makes it into this story, and it should. Geneticist Sarah Tishkoff spent years studying skin pigmentation genetics across the African continent, and her findings complicated the simple dark to light narrative even further. Africa alone, she found, contains more genetic diversity in skin color than the rest of the world combined. Some gene variants associated with lighter skin in modern Europeans actually trace their origins back to ancient African populations, present long before anyone ever left the continent. Skin color was never a single line running from dark to light. It was always a scattered set of experiments, running in parallel, shaped by local sunlight wherever humans happened to settle. And there's one more thread in this story that sounds almost like fiction. When early modern humans expanded into Europe and Asia, they weren't moving into empty land. Neanderthals and Denisovans, two other human species, had already been living in those low sun environments for hundreds of thousands of years. Their bodies had already adapted to the local light. When modern humans interbred with them, certain gene variants linked to skin pigmentation passed directly into the modern human genome. Some of the DNA shaping skin tone in people alive right now didn't originate in modern humans at all. It came from an entirely different, now extinct species of human. So skin color, it turns out, is not a fixed marker of ancient tribal identity. It's a dial, a relatively fast-moving evolutionary response to how much invisible ultraviolet light hits a particular patch of the Earth. Move a population far enough, keep them there long enough across enough generations, and that dial will shift, sometimes in as little as a few thousand years, which, in evolutionary terms, is closer to overnight than to eternity. There's something almost humbling in this. Skin color, one of the traits humans have used most often throughout history to divide, categorize, and judge one another, turns out to be one of the most superficial and recently formed traits in the entire human genome. Barely skin deep, in the most literal sense possible. Underneath, every population carries the same deep genetic history, the same African ancestors, the same original dark skin, adjusted locally by sunlight, like a thermostat responding to climate. And here's a detail that rarely makes it into the story, but should, because it proves the point better than anything else. The skin on your palms and the soles of your feet stays roughly the same pale tone across almost every human population on Earth, regardless of ancestry. Why? Because that skin is rarely exposed to direct sunlight, so it never faced the evolutionary pressure that shaped the rest of your body. Hidden there, on the parts of you that never see the sun, is a quiet reminder of how this entire transformation actually worked. Not identity, exposure. Now think about what this means for you, living right now in a world completely unlike the one that shaped any of this. You probably don't spend your days hunting across open savanna, and you probably don't spend your winters in a dim northern cave either. You spend most of your life indoors under artificial light, behind glass windows that block the very UV rays your skin evolved to respond to. And that mismatch has consequences. Vitamin D deficiency is now startlingly common across the modern world, even in sun-drenched countries, precisely because modern lifestyles have detached people from the sunlight exposure their skin tone evolved to expect. The dial that took thousands of years to calibrate now sits inside bodies living lives that calibration never anticipated. Think about sunscreen for a moment. Every time you rub it into your skin before heading outside, you're doing manually. In seconds, what melanin was doing for your ancestors automatically, across generations, blocking just enough UV to prevent damage, while still letting a little through. You're still living inside the exact same negotiation that shaped Cheddar Man's dark skin and blue eyes 10,000 years ago. You've just outsourced part of it to a bottle. And there's a deeper mirror here too. When you look at the range of human skin color across the planet today, from the darkest equatorial tones to the palest northern ones, you're not looking at different kinds of humans. You're looking at one very recent chapter in a single, shared, ongoing negotiation between human skin and the sun. A story still written in the DNA of people whose ancestors migrated only a few hundred generations ago, adjusting, generation by generation, to whatever sky happened to be above them. The categories humans have built on top of skin color, the ones used to sort people into rigid groups, to divide neighborhoods, to justify hierarchies, are far younger and far less biologically meaningful than the underlying science they claim to describe. The biology itself doesn't draw hard lines. It never did. It produces a continuous gradient, shaped by latitude and generations of exposure, with far more variation within any single population than most people ever realize. So look in that mirror again. The color staring back at you was never really about identity or ancestry stretching back to the dawn of humanity, or anything fixed and eternal at all. It's a sunscreen setting, dialed in by your ancestors' latitude, still being worn by you today, on a body built by a story far stranger and far more recent than you ever imagined.
If you enjoyed this video, don't forget to smash that like button, subscribe to the channel, and turn on the notification bell so you never miss a new video. Thanks for watching, and I'll see you in the next one.